Nash Equilibria instead of just one or none. And we'll use service learning as an example of the interactions. Game theory is very useful in so many different ways. I'd like to highlight some of the examples that they have here. Economic applications of game theory are in oligopolies, of course, but also any entry and exit of a firm, market equilibrium, auctions, insurance, principal agent issues, higher education, discrimination, public goods, pollution, many different examples of this. So very useful in so many ways. Equilibrium, remember, is the state in which forces balance each other so that we have a stable system. True or false? Equilibrium occurs when all internal forces are in balance. True. True or false? Equilibrium means everyone gets the same payoff. That's false. Balance is what we're looking for. In the case of a Nash equilibrium, we're referring to the interactions of players that have reached a point of stability so that neither player will change their strategy unilaterally. Now, how many Nash equilibria will there be? Of course, that depends on how many players there are and how many choices there are, but in the cases that we're looking at, there's a strategic interaction where there are two players with two strategies each, and in that case, you will either have one Nash equilibria, 0 Nash equilibrium, or 2 Nash equilibria. Well, the example we're going to use is service learning. Service learning, of course, is a wonderful program that helps you with so many different benefits, and you help the community partner as well. In service learning, the community partner has basically two choices when it comes to policy with their volunteers. The organization can be open to new ideas from the volunteer and allow them to be creative, or the organization can adopt strict policies of conduct and procedure which they require of the volunteer. We'll be drawing on our own experiences in various organizations and community partners to develop the Payoff Matrix. The listener is encouraged to consider the payoff for their own interactions as well. The volunteer also has two choices. The volunteer can conform to whatever rules are in place and follow them precisely, or they can be creative and attempt to add to the overall mission of the organization by applying their comparative advantages. In this payoff matrix, we see the four possible interactions which can take shape from the organization and the worker choosing from between these strategies. If community partner chooses a strict policy and volunteer conforms voluntarily, then both parties complete the interaction with nothing gained and nothing lost. We'll consider alternative interactions now. Suppose the volunteer tries to change their strategy and get creative. When the organization is strict, then this will result in a negative payoff for the worker. This negative incentive prohibits creativity and originality. But why is that a bonus for the community partner? The community partner benefits from having a strict policy and proving by use of the example on the volunteer that their strict policy is, in fact, their authority. What if the community partner is considering a change? Suppose that accepting of creativity is what the community partner wants, but the volunteer just wants to be told what to do. Then this will result in a negative payoff for the organization and acts as a disincentive to change policies. When we consider 3/4 of the payoff matrix like this, we can see what happens with a traditional worker interacting with a traditional organization. Any volunteers who tries a different strategy unilaterally will quickly return to a conforming strategy. And any managers who might be accepting of new ideas will become discouraged if the volunteers are not changing their strategy. Therefore, the Nash equilibrium is in the upper left-hand corner of the payoff matrix. We predict accurately that once this combination of strategies is established, that neither party will deviate from it. The organization will have strict policies, and the worker will conform. However, there is another payoff possibility to consider. And if the community partner is accepting of new ideas, the volunteer is creative as well, then we see that the benefit from the interaction will be to both of them. This is also a Nash equilibrium because once both have settled into this interaction, neither will change their strategy. This is what it looks like when we have two Nash equilibria. There are several other examples of interactions which present two Nash equilibria. The key element to them all is signaling. If the game can be converted from simultaneous to sequential, and if the first mover clearly signals the other one, then we could have a situation where, let's say, I go home and let her know that I am going home, and then that allows her to go home as well, and that creates a Nash Equilibria that neither one of us would deviate from. Similarly, there's another Nash Equilibrium here. If I work late and she works late, then both of us have another Nash Equilibria that neither one of us would deviate from, because that is also a point of stability. Signals are the important part of it. Otherwise, it's unpredictable what someone's going to do. So the other player, signal it clearly, will create predictable outcomes. Thank you very much.